Okay, this morning I'm gonna do all the problems from series 5, 6, and 7. Let's see if we can do it in 1 hour. Ready? Begin. Okay, the area under y equal x squared. Now we already did it from 0 to 1, but now we're gonna go 0 to 2. Now the key to doing this is you have to divide it into n equal parts. So if from here to here is 2, you divide that into n equal parts. Each part is going to be 2 over n. So we got 2 over n, 4 over n, 6 over n, all the way to 2n over n. And we're making circumscribed rectangles like this. So the area of the first rectangle is 2 over n, that's the base, times the height, which is 2 over n squared. Second rectangle. Each base is 2 over n times 4 over n squared plus 2 over n times 6 over n squared, all the way until you hit 2 over n times 2n over n squared. And then what can be factored out? You can factor out 2 times 2 squared, which is 8, and n times n squared, which is n cubed. And what's going to be left? 1 squared plus 2 squared plus 3 squared plus dot 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 plus n squared. And then, hey, you somebody. That is going to be, right, we know this formula, n times n plus 1 times 2n plus 1 all over 6. And then if we take the limit as n approaches infinity, that will give us the exact area. And if the degree of the top is the same as the bottom, you look at the leading coefficient, so that's going to be 16 over 6, which is 8/3. That is the exact area. Okay, number 2. So the first thing we need to do is write it in sigma notation, and we have 500 terms, don't we? And so how do you generate 135? That would be 2n minus 1. And how do you generate 357? That would be 2n plus 1. And then you multiply that out and you got 4n squared minus 1. So splitting it up into separate sigmas, n equal 1 to 500. 4n squared minus sigma 1. And of course the 4 can be thrown outside here. And then, hey, you somebody. Right? 1 squared plus 2 squared plus 3 squared all the way up to 500 squared would be 500 times 501 times 1001 all over 6. And then that's like 1 plus 1 plus 1 500 times. That's 500. And then there you go. I would suppose on the test, then if you write that just like the quiz, then that would be full credit. Okay. Write the first 3 terms of the power expansion for cosine squared x. Now, you guys already did it on the quiz, just doing long multiplication, but cosine squared x, hey, you want identity, yeah? Isn't that like 1 plus cosine 2x all over 2? You just take the identity for cosine 2x, or take this identity. Cosine 2x equals 2 cosine squared x minus 1, and solve for that, and whoa, this is an important one in calculus next year. So then if you know this identity, then you don't have to do long multiplication. So what you do is you take the power series for cosine 2x, which is 1 minus 2x squared over 2 factorial, plus 2x to the 4th over 4 factorial, minus 2x to the 6 over 6 factorial, right? Plus dot dot dot. You add 1 to it, and then divide the whole thing by 2. Actually, we don't need that term because we're only writing 3. And it looks like it comes out pretty nice. That way, no long multiplication. Okay, number 4. Write the first 5 terms of the power series of 1 minus x to the negative 2. Now this one you can either do long division or binomial theorem, but since we're going to use the binomial theorem on the test, let's practice the binomial theorem. So this is like 1 plus negative x to the negative 2. So a plus b to the n. So a to the n plus n. The power of a goes down by 1, the power of b goes up by 1. n minus 1, all over 2 factorial. The power of a goes down by 1, the power of b goes up by 1, plus n minus 1, n minus 2 over 3 factorial. The power of a goes down by 1, the power of b goes up by 1. That's the binomial theorem, and you just keep going. Now let's simplify this critter. 1 plus 2x plus, what is that going to be? 3x squared plus 4x cubed. I see a pattern. I think the next one's 5x to the 4. Anyway, what do we have to do? Oh, just write the first 5 terms. Come on. That's an insult. Okay, next one. Number 5. Write the first 6 terms of the power series expansion. Now, this one, we can use the binomial theorem if you group like, make it 2, make a group like 2 and 1 or 1 and 2. But I think this one, let's practice our long division. So isn't this the same thing as 1 over 1 minus x squared? And of course that bar means divide, so 1 divided by 1 minus x squared. Now, get ready with the Kleenex because this is going to bring tears to your eyes. 1 goes into 1 how many times? 1. Then you multiply it times the divisor. Subtract x plus x squared. Start the process all over. 1 goes into that how many times? X. Multiply x times the divisor. Minus x squared minus x cubed. Subtract, and you're going to have 2x squared plus x cubed. Then do it again. 1 goes into that how many times? Multiply times the divisor. 2x squared minus 2x cubed minus 2x to the 4th. Subtract, and we got 3x cubed plus 2x to the 4th. 1 goes into that how many times? 3x cubed. And then multiplied by the divisor again. 3x cubed minus 3x4 minus 3x to the 5th. Subtract, and we got, I think now we can see what's going on now. 5x to the 4th plus 3x to the 5th. 1 goes into that how many times? 5x to the 4th. And so what do we got? 5x to the 4th minus, this is really good for practicing your long division. 5x to the 5 minus 5x to the 6. Subtract, and then you get 8x to the 5th plus 5x to the 6. 1 goes into that how many times? 8x to the 5th. Holy Fibonacci. 1, 1, 2, 3, 5, 8. Woo! That was exhilarating. And it's not even 6:30 in the morning. Okay, number 6. Okay, we did this one in class, but like we just do it for the video again. Plus, well, there's 2 ways to do this problem. Now the first way is to look to find the limit of the sequence of partial sums. So first thing we should do is write out the term. So what is that going to be? 1 over 1 times 5. The next one's going to be 5 times 9, which is 45. And then we got 9 times 13. What's 9 times 13? That's not even right. 117? Okay, then we plug in 4. We got 13. 13 times 17. 13 times 17 is going to be 51, 181. Okay, so looking at the partial sums, the sum of the first term is 1/5. We're making a sequence of partial sums. Then the first 2, that would be 10/45, which can be reduced to what? Divide by 5. 2/9. I'm starting to see a pattern already. And then if you add the first 3 terms, you make the least common denominator. That's going to be 27 over 117. See, you guys gotta have arithmetic skills, man. So 3 over 13, I think that's enough. I see a pattern. So the explicit formula for the sequence is going to be n over, and then the common difference is 4. So 4 in and adjust. And that will converge to what number? What's the limit of the sequence? If the degree of the top and the bottom are the same, you look at the coefficients, 1/4. So if you keep on adding those numbers forever, you will get exactly 1/4. And then B was to decompose this into partial fractions. Well, let's just do it again. Let's do it really quick. So something over 4n minus 3 plus something over 4n plus 1. Multiply both sides by the LCD. Okay, and then we're going to use the Heaviside method. So plug in a number. How about like 3/4? So you get 1 equals, if you plug in 3/4 here, you get 4a plus 0. And so we just figured out a is 1/4. And then if we plug in negative 1/4, right, that'll make this thing 0. You get 1 equals 0 and equals negative 4b. So therefore b is negative 1/4. Yeah. Which means, of course, this was 1/4 and this was negative 1/4. So this original problem, if we decompose that thing into partial fractions, you're going to get 1/4 over 4n minus 3 minus 1/4 over 4n plus 1. And then if we write out the terms, if you plug in 1 here, you're going to get 1/4 minus 1/20 plus, then if you plug in 2, you get 1/20 minus 1 over 36, plus if you plug in 3, you're going to get 1 over 36, minus, plug in 3, 4 times 13 is 52, plus dot dot dot, and then look at this. This cancels this cancels this, this cancels this, blah 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 blah. And that just keeps canceling forever. So all you have left is 1/4. That's beautiful. So 2 ways to do this problem. Okay, number 7, find the interval of convergence. Now again, in order for you to find the interval of convergence, it has to be a geometric series, right? Well, in pre-calculus, next year calculus, you'll have more. So this is a geometric series. This is the common ratio right here. And in order for a geometric series to converge, the absolute value of r got to be less than 1. And so what does that mean? 2 sine x is between negative 1 and 1, divided by 2. So when is sine x between negative half and half? Well, I think if you just, these are numbers you're supposed to know for sine, right? Right? The pi over 6 family. And where is sine in between there? Well, that would be here and here. Now, if you have trouble writing it with the k notation, then just do this. Like, here's negative from negative pi over 6 to pi over 6, right? That's here. And then the next one's going to be 5 pi over 6 to 7 pi over 6. And then if you just keep on going, that's going to be what? 11 pi over 6 to 13 pi over 6. And then just put dot, 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 dot. Follow the same pattern. Or you can use the K notation like I have on the bottom. Okay, number 8. Now on the test, I'm going to tell you, hint, this is a power series. So, write out the first few terms. 2 over 1 factorial. Why don't we put 2 to the 1? 2 to the 2 over 2 factorial. 2 to the 3 over 3 factorial. So what's the power series that has the consecutive numbers factorial in the denominator? That would be e to the box, right? 1 plus box squared over 2 factorial. You guys like being babies? Write the box. Wah. Anyway, what number do I have to plug into the box to generate these numbers here? Well, it's obviously 2, right? So you plug in 2, and then I have to do any lomi? Well, look at this. This one starts here. So this is what we're trying to find right here, right there. So what do I do with this one? Subtract 1 from both sides. So the answer is e squared minus 1. Okay, we finished one page already. Okay, next one, series 6. Okay, look, this is the same area problem, except now it's y equal x cubed, and we're going from 0 to 2. So again, break it up into n equal parts. So from here to here is 2, If you divide that into n equal parts, each part's going to be 2 over n. 6 over n all the way to 2n over n. And we're making circumscribed rectangles. Or we call this a right endpoint Riemann sum. Okay, first rectangle, the base is 2 over n. Where shall we do this? Over here? Okay. And the height is going to be the y-coordinate of that point, which is 2 over n. And you plug it into the function and you get 2 over n cubed. Second rectangle, 2 over n, 4 over n cubed. The base is always 2 over n, that's why. And then 6 over n cubed. All the way until you hit the last rectangle here. The base is still 2 over n, and the height is going to be 2n over n cubed. Now, probably the toughest part for you, well, the morning glare, I hope you guys can see that on the camera. But, well, if the camera's here, I think you can see it. What can you factor out? Well, you can factor out a 2 and a 2 cubed. That would be 16. And then you can factor out an n and an n cubed, and that would be n to the 4th. And what's going to be left? 1 cubed plus 2 cubed plus 3 cubed plus dot 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 plus n cubed. And hey, you somebody, right? That's the formula for n times n plus 1 all over 2 quantity squared. And then we want to take the limit as n approaches infinity to get the exact area. And again, if the degree of the top and the bottom are the same, you look at the coefficient, so that would be 16 over 2 squared now. A lot of you making the mistake of thinking that's just 2, but that's 2 squared. So that would be 4. So the exact area of that region is 4. Okay, number 2. Find the interval of convergence again. Okay, so let's just skip right to the chase. This is a geometric series. This is the common ratio, right? The absolute value of r got to be less than 1. Solve this inequality, boom, and that will give you your interval of convergence. Now, the normal way to do it is the absolute value of gorilla is less than banana, then you got to do this, right? Negative gorilla, negative banana, and banana. And then you got to split it up into 2. So you solve this inequality, you solve that inequality, and then you take the intersection of the 2. Man, that will work. But if I were me, this is what I would do. I would go whoop, whoop, right? And then I'm going to multiply both sides by this because I know it's positive because it's got its absolute value. And remember I taught you this back in the second quarter. You guys probably forgot. But square both sides, since both sides are non-negative. And then now we have a difference of squares. Woo! And that's easily factorable. See, a squared minus b squared. That can factor as a plus b, which is 3x plus 1, times a minus b, and that would be x plus 1. And then you make a number line, and what do we have? Negative 1 and 1/3. And no, plus, minus, plus, and we're looking for less than 0. So wugga, 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 wugga. There's your interval of convergence between negative 1 and 1/3. But that's only if you remember how to do it, using the shortcuts I taught you. Otherwise, you just got to do this. Solve that, and then take the intersection of the 2. Okay, now number 3, here's an assortment of series. Now, on the test, I will tell you what technique to use for the infinite series to make it easier for you. Like this one, I'll probably either tell you decompose it into partial fractions or compute the limit of the sequence of partial sums, whatever. Okay, I think this one probably on the test is going to say compute the limit of the sequence of partial sums. So write out the first few terms. Plug in 1. 1 over, what is that, 2 times 5? 1 over, okay, plug in 2. 5 times 8. And then plug in 3. 8 times 11. Is that all you guys can handle? Okay, what's the sum of the first term? No, 1/10. What's the sum of the first 2? 1/8. What's the sum of the first 3? Ooh. 12 over 88 can be reduced to, what did I just say? 12 over 88 divided by 4. 3 over 22. I don't see a pattern! Well, this one's a little bit trickier. How about like, don't use that reduced form because you don't see a pattern. Why don't we change the 1/8 to 2/16? Now I see the pattern. Okay, so the explicit formula now is easy, right? So you gotta do whatever you need to do to see the pattern, right? So 1, 2, 3 is n, and then look, common difference 6. So 6n, and then adjust, plus 4. The limit of the sequence is 1, 6, which will be the sum of that infinite series. B. Okay, we got this. Oh, notice that starting with 0 now. Don't fall for that. Cosine n pi. This is going to make it alternate over 2n plus 1. Now, on the test, I'll probably say, hint, this is a power series. Well, write out the first few terms. If I plug in 0, you get cosine of 0, so it's 1. Plug in 1. Cosine pi is -1, so you're going to negative 1/3. And then you can get plus 1/5, minus 1/7, plus dot, dot, dot. Now, what's the only power series that has the odd numbers factorial in it? Not even factorial, just the odd numbers. That would be tan inverse box, right? So tan inverse box equals box minus box cubed over 3 plus box to the 5 over 5 minus box to the 7 over 7 plus dot, dot, dot. What number do I need to plug into the box? Rhymes with bun. It's 1. So this is equal to tan inverse 1, which of course we know is equal to pi over 4. Okay, so first of all, we can take the 1/2 and throw it out in the front, and then, hey, you somebody. Now, come on, we talked about this in class, but if you don't remember, here, plug in some numbers. Hey, you are the harmonic series, right? Well, half of it, right? So the harmonic series, what do we learn about it? Diverges to infinity. So if you have a series that diverges to infinity and then you take half of it, what up with that? That also diverges to infinity. Please don't say 500,000. D, sigma n equal -1. Now, how can you tell just by looking at this is geometric? Duh, you have a number to the nth power. This is a geometric series. So, and the common ratio is 3/5, right? Which means it's going to converge, right? The absolute value of r is less than 1. So all you got to do is use the formula, first term over 1 minus r. Now, how do I figure out the first term? Plug in -1. That's the key to the problem right there. So if I plug in -1 there, that's going to be 2 times 5/3. All over 1 minus the common ratio. There you go, that's your answer. I will leave the simplifying to you. That was D. What did we get? Ooh, we got complex number. 1/2 plus √3 over 2i to the n. Okay, so first thing, change this to archistheta form. So if you draw the picture, here's the real and the imaginary axis. If I go 1/2 to the right and radical 3 over 2 up, how far from Oregon am I going to be? 1. And then what's that angle right there? That's pi over 3. So, and then we're going to raise it to the nth power. So the first thing we do is plug in 1. So you're going to get 1 kiss pi over 3. If you plug in 2, again using de Moivre's theorem, 1 squared is 1. And then you multiply the angle by the power, so that's 2 pi over 3. And then if you plug in 3, 1 cubed is 1. And you multiply the angle by 3. And you just keep on going until you hit 100. Now, the thing you need to know in this problem is the pattern. Okay, here's a circle of radius 1 in the complex plane. How do you draw this vector? It's a vector 1 unit long making an angle of pi over 3. The next one is 2 pi over 3. The next one is pi. I see a pattern. Every 60 degrees, you're going to add a new one. Katuka, katuka, katuka. And what do you notice about those 6? They all cancel out to 0. So the pattern right here is every 6 cancels out to 0. So if you have 100 terms, what's going to happen? Well, you divide 100 divided by 6. 6 goes into 10, 1 time remainder 4. 6 goes into 40, 6 times remainder 4. So there's 16 groups of 6, but they all cancel out to 0. There's a 4 remainder. So here's the first 4. 1, 2, 3, 4. Those are the 4 that are left over. Everything else cancels out to 0. And then of course, this one cancels that one because they're pointing the opposite way and they're the same length. So these are the only 2 that are left right here. And that would be 1 kiss 2 pi over 3 plus, and then that one is 1 kiss pi. And that's it. And then of course, you gotta change it back. And again, let me remind you, what does kiss stand for? Cosine theta plus I sine theta. And same thing with that, cosine theta plus I sine theta. Squeeze it in, baby. And then what do we got there? Negative half plus root 3 over 2i. And that one's going to be negative 1 plus 0i. So if you add the real parts together, you get negative 3 halves. And if you add the imaginary parts, root 3 over 2i. Voila! Okay, next, okay, F. Okay, so this one, we have 100 terms. And then we're going to write the formula. So 1, 2, 3 would be n. 1, 3, 5 is 2n minus 1. There you go. So we've seen this problem before. Multiply that out. So that's 2n squared minus n. So break it up into separate sigmas. So 2n squared minus sigma n equal 1 to 100n. And then the 2 can be thrown on the outside. And then, hey, you somebody. What's 1 squared plus 2 squared plus 3 squared all the way to 100 squared? That would be 100 times 101 times 201 all over 6 minus, and this, hey, you somebody. What's 1 plus 1 times 2 times 3? I mean 1 plus 2 plus 3 all the way to 100. 100 times 101 all over 2. And on the test, good enough. Okay, number 4. Okay, first of all, write the power series for natural log 1 plus box. That would be box minus box over box squared over 2 plus box cubed over 3 minus box to the 4 over 4 and so forth. I don't know how many we need here. Using, oh, it says use the first 3 terms to approximate natural log of 1.2. Natural. This sounds like a problem we did before. Now, so what do I have to plug in the box to get 1.2? Well, 1 plus what will give you 1.2? 0.2, which is of course 1/5. So you put 1/5 in the box. Okay, so use the first 3 terms. So add up the first 3 terms. 1/5 minus 1 over 25 times 2 minus 1 over 125 times 3. Okay, well, add those numbers. I'll leave that to you. And what's the magnitude of error? Well, this will, you can use Leibniz's theorem. So the magnitude of error will be less than the first term you didn't use, which is this. So that would be 1 over 5 to the 4th, which is 625 times 4. I will leave the computation to you. Leibniz's theorem is quite easy to use. Just make sure you can use it though. Okay, number 5. Using the power series for side box, okay, so here, which is box minus box cubed over 3 factorial box to the 5 over 5 factorial minus box to the 7 over 7 factorial plus dot dot dot. Okay, it says how many terms are needed to approximate sine of 0.5, so that means we're going to plug in 0.5 there, which is a half. So that the magnitude of error is less than 10 to the negative 4. So we want to find the first term that's less than 10 to the negative 4, which is 1 over 10,000. So compute each term. Are you less than 1 over 10,000? No. So we go to the next one. So that's 2 cubed times 6, 48. Are you my mother? No. So we go to the next one, which is 1 over 2 to the 5th, which is 32 times 5 factorial, which is 120. So 32 times 12 is 64, 32, 384, and 0. Are you my mother? Is that less than 1 over 10,000? No. So then we go to the next one. So 1 over 2 to the 7th, that's 128 times 7 factorial, which is 5,040. You guys really want to multiply that out? Here, let's do this then. Yeah, let's just do it for fun. 2, 3, 4 0 8 0 1 0 5 0 4 2 1 5 4 6. You gotta add the 0 there. Wow, that's a big number, man. 645,120. I hope I did that correctly. If not, too bad. Is that number less than 1 over 10,000? Yes, which means add everything before it then. So the answer is 3 terms. So if you add the first 3 terms, you will be within this of the actual answer. But if you're within this of the actual answer, you will be within 1 over 10,000 of the actual answer. Okay, number 6, write the first 3 terms of this power series, e to the x over cosine x. Well, again, this is just to see if you can long divide. So e to the x, 1 plus x squared over 2 factorial, x to the 4 over 4 factorial. And we're going to divide that by cosine x, which is 1 minus x squared over 2 factorial, plus x to the 4 over 4 factorial. Hopefully we don't need any more. 1 goes into 1 how many times? Oh, I like when the first number is 1. Something's wrong here. Right here. This is x to the 3 over 3 factorial, dumbo. Okay, anyway, so multiply, we did, subtract. Now, notice that you gotta, so this, there's no x term here, so when you subtract, you're just gonna get x. This minus this is gonna be plus x squared. This minus nothing is gonna be x cubed over 6. Okay, hopefully that's all we need. Okay, 1 goes into x. How many times? X. Multiply x times the divisor. X minus x squared, x cubed over 2. Oh yeah, that's all we're going to need. Okay, subtract. So x squared minus nothing is x squared. And really, that's all you need. How many terms are we writing? Only 3. Oh, that's all you need. 1 goes into that how many times? X squared. Finished. See, I asked you to write 3 terms. 3 terms is really not that bad. Okay, now number 7. We're at the end of this one. Hallelujah. 1 plus x squared to the negative 3. Write the first 4 terms. Now you can do long division, but again, for the test, let's practice our binomial theorem. So a plus b to the n. A to the n plus n. The power of a goes down by 1. The power of b goes up by 1. n minus 1 over 2 factorial. The power of a goes down by 1. The power of b goes up by 1. Let's just do one more. n minus 1, n minus 2 over 3 factorial. The power of a goes down by 1. The power of b goes up by 1. That's the binomial theorem. Simplify. 1 minus 3x squared plus 12 over 2 is 6 x to the 4 minus 10 x to the 6 plus dot dot dot. Okay, that's the first 4 terms. Find the 100th term. You know what would be a better problem? Like if I were writing the test based on this, I would say write this series using sigma notation and that will answer part B. So let's just do that. And then you can just plug in 100 for n, right? Okay, let's look at first of all. It goes positive, negative, positive, negative. It alternates. So what will make it do that? Negative 1 to either the n or the n plus 1. But since we want the first term to be positive, n plus 1. Now look at the powers of x. That's like the next easiest thing. Let's put x to the 0 here. X to the, okay, how do you generate the number 0, 2, 4, 6? That's arithmetic with common difference 2. So that's going to be 2n. And then you adjust minus 2. Now for the numbers, the coefficients. 1, 3, 6, 10. Hey, you somebody. That's right, that's the triangular numbers. N times n plus 1 over 2. And if you forgot that, suffer! Well, you guys know how to derive it now, right? We did that last chapter, right? 3 equations, 3 variables. But I told you, triangular numbers are going to come up. And there you go. So if you want to find the 100th term, just plug in 100. It's not that hard. Okay, we're on the last page. Okay, hope the battery doesn't run out. Okay, find the interval of convergence, which must mean it's geometric. So what's the common ratio in this series? Negative 3 tangent squared x, right? So the absolute value of r gotta be less than 1 in order for a geometric series to converge. Solve this inequality and we're in business. Okay, we can take away the negative sign, right, because the absolute value of -1 is 1. And then we don't need this absolute value anymore. You know why? Because tangent squared is always already non-negative. So all we gotta do is solve this inequality now. So divide by 3. Right? Because when you square something, it's not going to be negative. Okay, now what? Now what do you do? Well, doesn't this simply mean tangent x is between 1 negative 1 over root 3 and 1 over root 3? You know what? I changed my mind. Let's do it this way. Square root both sides, because let's see if you remember anything. What's the square root of something squared? That's right, absolute value. And then now, this means tan x is between 1 over root 3 and negative 1 over root 3. Okay, so now we just got to know your trig. Now, where is tangent 1 over root 3 or negative 1 over root 3? And again, that's the pi over 6 family, just like that other problem we did. And where would tangent be in between it? Well, it would be here and here. There you go. And that's going to be like the same answers as the other problem, right? So again, if you cannot write the k notation, then don't write it. Just go, okay, that would be negative pi over 6 to pi over 6. And then over here would be 5 pi over 6. Why am I writing it all again? And then you just go dot, 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 like that. Actually, it would be better to put one more, but we've seen this one before, so. Okay, next, number 3. This looks like a long division exercise again. Okay, write the first 3 terms of this power series. So tan inverse x is x minus x cubed over 3 plus x to the 5 over 5, right? Odd function. And we're going to divide that by natural log 1 plus x, which is x minus x squared over 2 plus x cubed over 3. Hopefully we don't need any more. X goes into x how many times? 1. Come on, the first one is so easy. Multiply 1 times the divisor, x squared over 2 plus x cubed over 3. Subtract. Okay, now look, there's no x squared term up here, so that's like 0x squared minus that. So that's going to be 1/2 x squared. And then that minus that is minus 2/3 x cubed. Correct? Hopefully we don't need anything else. X goes into that how many times? 1/2 x. So you get 1/2 x squared minus 1/4 x cubed. Subtract. So we got negative 2/3 minus negative 1/4, so that's like plus 1/4. So the least common denominator will be 12, so that's going to be negative 8 plus 3, so that's negative 5/12 x cubed. And x goes into that how many times? Minus 5/12 x squared. There you go, 3 terms, not that bad again. You just gotta practice a few times. Yeah, we're doing this pretty quickly. Oh, not really. Okay, here we go. 1 plus x squared. This looks eerily familiar. Write out the first 4 terms, and again, binomial theorem. A to the n plus n. The power of A goes down by 1. The power of B goes up by 1. N minus 1 all over 2 factorial. The power of A goes down by 1. The power of B goes up by 1. Now what the heck? Plus n minus 1. N minus 2 over 3 factorial. The power of A goes down by 1. The power of B goes up by 1. That's the binomial theorem. Simplify. 1 minus 2x squared plus 3x4 minus 4x6 dot dot dot. Okay, that's the first 4 terms. Now find the 100th term. And again, for practice, why don't we just write sigma notation, because I think that's what you're going to do on the test. So first thing, notice it goes positive, negative, so that would be negative 1 to the n plus 1, right? And then look at the powers of x. 0, 2, 4, 6. How do you generate those numbers? That's arithmetic. 2n minus 2. And then, how do you generate the numbers 1, 2, 3, 4? That's a dot n. There you go. So if you want the 100th term, just plug in 100. Woo! Okay, what's the next one? Oh, area 5. Can we squeeze it in here? Oh, now we got x to the 4th now. Okay, break it up into n equal parts, and we're going from 0 to 2. So again, if this is 2 units and you divide it into n equal parts, each part is going to be 2 over n. 2 over n, 4 over n, 6 over n, all the way until you get to 2n over n, and we make circumscribed rectangles. So the area of the first rectangle, the base is 2 over n, and the height is the y-coordinate of that point, which is 2 over n to the 4th now. Okay, the base is always 2 over n, and the height is going to be 4 over n to the 4th. Here's the base. The next height is going to be 6 over n to the 4th, all the way until you hit the last rectangle, 2 over n, and then the height is the y-coordinate of that point, which is 2n over n to the 4th. Okay, what can be factored out? Well, a 2 times 2 to the 4th, which is 32, and an n times n to the 4th, which is n to the 5th. And what's going to be left? 1 to the 4th plus 2 to the 4th plus 3 to the 4th, all the way until n to the 4th. Well, Mr. Park, I don't know a formula for that. Well, that's why I told it to you right there, see, in the problem. That is equal to 32 over n to the 5th. Okay, let me read it off here. What does it say? N times n plus 1, and 2n plus 1, times 3n squared plus 3n. Oh, that would be a good problem to make you derive that then. There you go. See, I told you the formula. Can't be any easier. And then if you want the exact area, you take the limit as n approaches infinity. And again, if the degree of the top and the bottom are the same, which they are, n to the 5th, you look at the leading coefficients. So that would be 32 times 2 times 3, all over 30. Whoa! So what? 2 goes into that 15 times, but 3 goes into that 5 times, so 32 fifths. The exact area right there is 32 fifths. Okay, keep going. Oh! Should I have left that up? Too bad, rewind. Okay, what time? We're nearing an hour already. That machine better be going. Somebody's gonna get hurt. Okay, A. Compute n equal 1 to 100, n plus 2 cubed. Actually, now that I wrote this problem a long time ago, but now that I look at it, I think we can do it another way, but you know what, I'm gonna do it the way that I wanted you to do. Like, multiply this out. Okay, how do you multiply out n plus 2 cubed? N cubed, again, binomial theorem. 3 choose 0 plus 3a squared b, so that would be, what is 3 times that squared that? 6n squared. Plus 3 times that squared, so that would be 12n, plus that cubed, which is 8. And then split it up into separate sigmas. So that would be n cubed plus sigma, n equal 1 to 100. 6n squared, well, we can pull out the 6. And then sigma, n equal 1 to 100. 12n, but we can pull out the 12. Plus sigma, n equal 1 to 100, 8. Okay? And then, hey, you somebody. What's 1 cubed plus 2 cubed plus 3 cubed all the way to 100? 100 times 101 all over 2 quantity squared. Plus 6 times, hey, you somebody. What's 1 squared plus 2 squared plus 3 squared all the way to 100 squared? 100 times 101 times 201 all over 6. Plus 12 times, hey, you somebody. 100 times 101 all over 2. And then over here, what is 8 plus 8 plus 8? 100 times, that would be 800. And then just leave it like that. That'll be fine. Of course, the other way to do this problem is just use the sum of cubes formula, right? Except when you plug in 1, you're going to be starting with 3 cubed. And then you're going to end at 102 cubed. Somebody going, what the heck are you talking about? Here, I'll just show you. If the camera runs out, you're in trouble. All the way till, if you plug in 100, you're gonna get 102 cubed. Hey, you somebody, right? Isn't that equal to 102 times 103 all over 2 quantity squared? Yeah, but Mr. Park, the thing starts at 3 cubed. Yeah, so then just all you gotta do is subtract these two from it right there. That's what this is. So it's gonna be that minus 1 cube plus 2 cube. But that's not what I planned. So probably on the test, I'll just give it to you, I'll multiply it out. That's what's probably gonna happen. Okay, now we got the assortment of series right here. Okay, here we go. This is the, how many times are we gonna do arcus theta? Well, enough until you get it. Okay, change that to arcus theta form. So, here's your real and imaginary axis. If I go root 2 over 2 to the right and root 2 over 2 up, how far from origin am I? 1. And what's that angle? Pi over 4. Okay, so plug in 1 through 100. If you plug in 1, you get 1 is pi over 4. If you plug in 2, 1 squared is 1, and then you multiply the angle times 2. And then 1 is 1 to the third, and you multiply the angle by 3. And you just do this 100 times. And again, we need to find the pattern. So here is a circle of radius 1. Graph the first one. Woo-hoo! The second one. Woo-hoo! The third one. Oh, so every 45 degrees there's going to be 1, Monsieur Park. So that means every 8 cancels out to 0. That's right. So we divide 100 by 8. So 8 goes into 10, 1 times 2, remainder 4. There's 4 remainder. So here, 1, 2, 3, 4. Those are the 4 leftover ones. And none of them cancel. So you actually gotta like write them all out. So what is that? 1 kiss pi over 4 plus 1 kiss pi over 2 plus 1 kiss pi over 3 pi over 4 plus 1 kiss pi. And then you gotta change them all back into the a plus bi form. Now if I were writing a problem for you, I would make almost all of them cancel out. So there's only like 1 or 2 left. Like 4 left over, that's kind of mean. But whatever, and you guys know how to change that back, yeah? Of course you do. Okay, next problem. Okay, so on the test, I will tell you how to do this. I would say by computing the limit of the sequence of partial sums, or by decomposing it into partial fractions. Okay, but I think this one I will tell you to look at the limit of the sequence of partial sums. So, write out the first few terms. If I plug in 1, you get 1 over 2 times 3. And then if you plug in 2, you get 3 times 4. If you plug in 3, you get 4 times 5. And then if you plug in 4, you get 5 times 6. So forth. So, partial sums, sum of the first term. Sum of the first 2. Woo! What would that be? 1/4. Sum of the first 3. That would be 5. 6 over 20. 6 over 20 reduces to what? Kind of early in the morning. 3/10. Sum of the first 4. 1/3. I don't see a pattern. Well, if you remember the last problem, we might have to unreduce some of these fractions. Like 1/6, you can't do anything with that. Like maybe we should write 1/4 as 2/8, because then see how you get 1, 2, 3? And then what about 1/3? You probably want to write that as 4/12. And then, oh, now I